Here we're taking a car trip. We're going to be driving 90 miles total. We're going to be traveling at 40 miles per hour. We have some questions. What will be our total time for the trip? How far do we travel in 17 minutes? I want to write an expression for how far we'll travel in t minutes, and an expression that represents how far we have still yet to go after t minutes. So let's take some times here. At 1 hour, 90 miles per hour means we travel 40 miles per hour, not 90 miles. 90 miles is the distance of the trip. At 40 miles per hour, that means that in 1 hour we travel 40 miles. And this would be in, by the way, hours, miles, and miles. And then 90 minus 40 equals 50 remaining miles. So at hour 2, see we've traveled 80, right? 2 40-minute or 40-mile chunks. And our remaining distance is 90 minus 80, which is 10. And I think it's pretty clear, though, that if we go for a third hour, that's another 40. So this is 1 times 40, 2 times 40, 3 times 40 is 120. 90 minus 120, we have negative 30 miles to go. That doesn't make any sense. We've gone too far. So our total time is going to be somewhere between 2 and 3 hours. Well, one thing that we can do here, we can bring in our formula for distance, rate, and time. And we have rate times time equals distance. We know rate, we know distance. We just want to solve for time, so I'm going to divide by rate on both sides. Rate cancels with rate. And we have time equals distance over rate. Okay. So let's see. So we want our distance to be exactly 90. So let's see. Time equals 90 over 40. And so t equals, well, 90 over 40 is 9/4 of an hour. So over here, so that means that 9/4 of an hour is kind of a weird number. 9/4 times 40 should equal 90. Let's check. 9 ABC4 times 40 gives us 90 miles. Okay. And then we would have 90 minus 90 equals 0. Okay. 9/4 of an hour, by the way. 9/4, that's the same as 1. Yes, it's 2. Sorry, 2 and 1/4. Well, 1/4 of an hour is 15 minutes. So that's 2 hours, 15 minutes. Okay. So next, let's take a look at writing an expression that will represent this. But we want our time to be in minutes, right? So what we can do is, a couple things we can do. If I want to change time into minutes, time into minutes, and distance, and remaining, so a new table, and we want the distance to be measured in miles, and remaining measured in miles. My handwriting is terrible. We want minutes, though. So we could go over here to the side, and I've got 40 miles in 1 hour. In 1 hour. That's the same as 40 miles in 60 minutes. 60 minutes. So if I wanted to scale this down to 1 minute, I would have to divide by 60. So I'm going to divide by 60 over here, and 40 divided by 60 we can write as a fraction, 40 over 60, which simplifies to 4 over 6, or 2 over 3. All right, so 2/3 of a mile, 2/3 of a mile for 1 minute. So over here, let's put that down. We're traveling 1 minute. We will go 2/3 of a mile, and we will have remaining, okay, 90 minus 2/3. And if I drove 2 minutes, that would be, so 1 times, that would be 2 times 2/3, which is 4/3. And I'd have 90 minus 4/3 of a mile, and so on. And if I travel t, following the pattern, it would be 2/3 t. And over here, I got this number each time from over here, and so we have 90 minus 2/3 t for our remaining distance. So this formula here, this expression represents how far we traveled. This expression represents how far we have yet to go. In order to do that, again, we had to first turn our miles per hour rate into a miles per minute rate, and then we'd go, well, instead of up here, 40 miles per hour was 40 miles in 1 hour, but if we turn that into a miles per minute, then we found it was 2/3 per 1. It was easy to write an expression from there.